Take a look around the room you're sitting in. It feels stable, safe. But the exact spot you are occupying right now was once a completely uninhabitable landscape, boiling beneath a sea of 8,500-degree magma. Later, that same geographic coordinate was buried under miles of solid, crushing ice, freezing everything in total darkness. Earth's biography is a catalog of apocalyptic cataclysms. Every era of total destruction left behind a specific set of physical and chemical wreckage. This debris formed the foundation for the complex world we inhabit today. 4.5 billion years ago, there was no Earth. A massive supernova explosion forced immense clouds of cosmic dust and gas to collapse in on themselves, igniting a brand new star, our Sun. The remaining dust and debris swirling around this new star smashed together through intense gravitational pull. This demolition derby formed early Earth, a 1,500-degree sphere of toxic rock. Then came the first necessary disaster. A rogue, Mars-sized planet named Theia slammed directly into this molten Earth at an unimaginable speed. The collision was so violent that massive chunks of Earth were ripped away and ejected into space. Over time, that floating rubble bound together in orbit to form our moon. That specific impact stabilized Earth's erratic wobble, and its gravity generated the tidal forces that would eventually support vast, churning oceans. For millions of years, the cooling crust was bombarded by relentless meteor showers. These space rocks delivered payloads of frozen water and vital minerals directly to the surface. Deep within these newly formed oceans, the very first microscopic life emerged. These simple organisms thrived in the extreme heat and pressure of underwater volcanic vents. As they consumed minerals to survive, these early microbes began excreting a gas that had never existed in large quantities on Earth before: oxygen. But to the life forms of that era, oxygen was incredibly lethal. It wiped out almost every living thing and chemically reacted with the iron in the oceans, literally rusting the planet and turning the water's blood red. The oxygen-rich atmosphere we require to breathe began as a lethal poison that triggered a global extinction. As the planet aged, shifting tectonic plates cracked the Earth's crust wide open. This unleashed massive global volcanic eruptions that literally boiled the oceans. Millions of tons of carbon dioxide and ash choked the sky, leading to torrents of highly corrosive acid rain. This chart shows the catastrophic result of that atmospheric blockade. Global temperatures plummeted, plunging the planet into a deep freeze. Earth was trapped in an agonizing loop. Internal volcanic heat slowly melted the ice, only for the planet to violently freeze over once again. To survive this brutal whiplash between fire and ice, simple marine organisms were forced to adapt. They began grouping together, building larger, more complex bodies that could withstand the shifting extremes. Without this brutal climate whiplash, marine life would never have developed the biological complexity needed to eventually crawl out of the waves and survive on land. Fast forward a few 100 million years, the supercontinent Pangaea split apart, creating coastlines and lush, oxygen-rich forests. This abundant food supply allowed reptiles to grow to massive sizes, dominating the food chain. Then, a rock weighing 4.5 trillion kilograms, larger than Mount Everest, hurtled toward the surface at 80,000 kilometers per hour. The impact unleashed the energy of 100 million nuclear bombs. Life at ground zero was instantly vaporized, and a colossal cloud of burning dust rapidly enveloped the globe. The real killer came in the weeks that followed. The ash blocked out the sun, completely halting photosynthesis, freezing the surface and starving the giant herbivores and the predators that hunted them. This apocalypse wiped out the giant apex predators, leaving the surface entirely open for tiny subterranean mammals to emerge and inherit the Earth. Millions of years later, global temperatures shifted once more. The lush, dense forests of Africa began drying out, slowly transforming into wide, arid savannas. Our tree-dwelling ape ancestors faced starvation. To find food, they were forced to abandon the safety of the dying canopy and venture out onto the exposed, dangerous plains. Navigating tall grass and hunting in the open required a new posture. They stood fully upright on two legs, freeing up their hands to wield stones, sticks, and eventually tools. human intelligence, tools, and culture grew from a desperate survival response to a collapsing local ecosystem. It took 4.5 billion years of relentless violence, freezing, burning, and mass extinctions to finally sculpt a habitat perfectly balanced for human life. Yet today, we are rapidly altering the atmosphere, pumping out carbon and pollutants at a pace faster than any previous biological species in history. Our massive artificial carbon emissions are now mirroring the geological effects of the ancient volcanic eruptions and asteroid impacts that choked the deep past. The rock beneath our feet has seen this all before. History proves the planet will easily survive the next climate catastrophe, but we likely will not.